Welcome to my channel Arun Kumar at Exam Bureau. This video is related to the topic design of steel structures. And the subtopic discussed in this video is Introduction to Bolted Connection. Advantages of steel structures over concrete structures. 1. The value of modulus of elasticity is higher. The value of E of steel is 2 into 10 power 5 north per millimeter square, which is at least 10 times higher than M25 concrete. E equals 5,000 root EFCK equals 5,000 root 25 is equal to 25,000 north per mm square. Higher value of E indicates greater strength of any material. 2. The steel has a higher strength-to-weight ratio because of its high value of E. Modulus of elasticity equals stress by strain. Stress is inversely proportional to area. As E increases, a decrease. For the same load-bearing capacity, a steel structure will require less material and therefore weigh less than a concrete structure. This is the comparison of steel structure with equivalent concrete section. You can see clearly steel has less dimension compared to concrete. 3. Because steel sections are lighter in weight, they can be easily transported. 4. Less construction time is required for steel structures compared to concrete, because concrete structures involve time period for curing of concrete. Disadvantages of steel structures over concrete structures. 1. The steel sections are costly as they are manufactured from iron ore. 2. The steel structure is prone to rusting and require frequent maintenance. 3. The steel structure is damaged due to fatigue loads. 4. The steel structures has higher thermal coefficient of conductivity compared to concrete. Physical properties of structural steel is 800. Density is 7,850 kilograms per meter cube. Modulus of elasticity is 2.0 into 10 power 5 Newton per mm square. Poisson's ratio is 0.3. Modulus of rigidity is 0.769 into 10 power 5 Newton per mm square. Coefficient of thermal expansion is 12 into 10 power minus 6 per degree Celsius. Hot-rolled steel sections available in market. I-section, channel section, T-section, angle section, bar section, tube section. Limit state of strength, IS 800. 1. Failure by buckling. 2. Failure by rupture of critical section. 3. Failure by loss of stability. 4. Failure by fatigue. 5. Failure by brittle fracture. Limit state of serviceability, IS 800. 1. Deformations and deflections. 2. Vibrations in any of the components. 3. Cracks due to fatigue. 4. Corrosion. 5. Fire. What is a bolt? A bolt is a mechanical fastener, typically consisting of a cylindrical rod with a movable nut on one end and a head on the other. The thread of a bolt is the spiral portion of corrugation. The shank of a bolt is the plain cylindrical portion. How bolts are inserted in plates. Drill the holes on the overlapping portion. The bolts are inserted in the holes and tightened. Types of bolted joints. Lap joint. Lap joint is formed by the overlapping of the connecting plates one above the another. This is the lap joint of 2 plates. This is the lap joint of 3 plates. Lap joint of 4 plates. 2. Butt joint. Butt joint is formed by the joining of the 2 plates at the edges. Butt joint is classified into 2 types, a single cover butt joint and B, double cover butt joint. A butt joint where a single cover plate is used to ensure connection with the bolt. Bolt holes are provided on each side of the cover plate to ensure connection of cover plate with each connecting plate. A double cover butt joint is a butt joint where two cover plates are used to ensure connection with the bolt. Failure of bolted connections. 1. Shear failure. Shear failure is the failure of cross-section of a bolt and occurs along a shear plane. The shear plane is the specific area within the bolt where this force is most concentrated. This is the shear plane, and the shear plane passes through the cross-section within the bolt, causing shear failure. The number of shear planes in single cover butt joint is 1. The number of shear planes in double cover butt joint is 2. Bearing failure of bolt. The bearing stresses act on the curved surface of bolt when forces are applied on the plate. Bearing failure of bolt occurs when the cylindrical shape of the surface distorts. 3. Bearing failure of plate. As per Newton's third law, when bearing stresses are developed on the bolt, bearing stresses in opposite direction are developed on the holes of the plate, which is in contact with the bolt. Bearing failure of plate occurs when the bolt holes of the plate are widened. As a result, bolt holes are widened, which indicates bearing failure of plate. 4. Tension failure of bolt. Tension failure of bolt occurs when the connecting plates are stretched. Types of bolts based on mode of transfer of force. 1. Bearing type bolt. This type of bolt transfer the force by bearing that is curved surface and shear mode that is cross-section of bolt. 2. Friction type bolt. When the bolts are over-tightened, the clamping forces, compressive stresses, are developed which compress the plate. Whenever the normal forces are present, the frictional forces are generated on the surface as F equals mu times N. In order to understand this, when the block moves in forward direction, the frictional force act in opposite direction due to the weight, which is a normal force. Similarly, clamping forces act as normal forces and frictional forces are generated on the junction between the plates. Grade of bolt, Indian Standards 800. Bolts are designated by means of their 1. Diameter. Example, M20 means bolt diameter as 20 millimeters. And number 2. Strength. Example 4.6 denotes the ultimate strength of bolt as 400 Newton per square mm. First digit multiplied by 100, and 0.6 as the ratio of yield strength to ultimate strength of bolt. Shear capacity of bolt. The capacity of the bolt to resist its shear failure is called shear capacity of the bolt. Since the shear failure occurs along the shear plane, the formula for shear capacity include the number of shear plane. VNSB = FUB by root 3 NN INB plus NS ASB. FUB is ultimate tensile strength of bolt. NN is number of shear planes passing through thread. NS is number of shear planes passing through shank. NB is sectional area of thread, 78% of shank area. SB is sectional area of shank. VNSB is nominal shear capacity. VDSB equals VNSB by gamma MB. In the figure 1, NN equals 1 as the shear plane passes through the thread. In the figure 2, NS equals 1 as the shear plane passes through the shank. In the same way, these are related to single cover but joint. In the double cover but joint, there are two shear planes. Two cases can arise. 1. Both shear planes passes through the thread, and 2. One shear plane passes through thread and the other through shank. V into PB equals 2.5 K into B into D into T into FU. FUB is ultimate tensile strength of bolt. KB is smaller of E by 3D naught, P by 3D naught, 0.25, FUB by FU1. E is edge distance, P is pitch, D naught is bolt hole diameter 2 millimeters greater than the bolt diameter. FU equals ultimate strength of the plate. V and PB, nominal bearing capacity. Frictional strength of bolt. VNSF equals 2.5 mu F NEK H F naught. VNSF is the nominal shear capacity of the HSFG bolt. Mu F, coefficient of friction, and E is the number of interfaces / shear planes. KH equals 1 for nominal holes, 0.85 for oversized and short slotted holes, and 0.7 for long slotted holes. F naught equals A and B F naught. F naught equals 0.7 FUB. VDSF equals VNSF by gamma MF, where partial safety factor gamma MF is 1.1 at service load and 1.25 at design load. Prying action of HSFG bolt. Additional tensile force developed in a bolt as a resulting of flexing or deformation of a connection component, such as a beam end plate or leg of an angle or flanges of T-section. Greater stresses are developed due to deformation of plates. Some common terminologies of bolt. Pitch is the distance between centers of two adjacent bolt along load direction. Gauge is the distance between centers of two adjacent bolt perpendicular to load direction. Edge distance, E, is the distance of the bolt from edge perpendicular to the direction of load. End distance, E, is the distance of the bolt from edge parallel to the direction of load. Some codal provision as per IS 800. The minimum pitch is 2.5 D bolt diameter. The maximum pitch is 32 T or 300 millimeters, whichever is less. The pitch lying in the direction of tensile stress shall not exceed 16 T or 200 millimeters and 12 T or 200 millimeters in case of compressive stress. The minimum edge distance and end distance is 1.5 do bolt hole diameter for machine cut and 1.7 do for hand cut. The maximum edge distance shall not exceed 12 T epsilon. Epsilon is 250 by yield stress whole power half. When the members are exposed to corrosive influences, the maximum edge distance is 40 millimeters plus 4T. Provision for long joint. When length of joint LJ exceeds 15 times the diameter of the bolt, the shear capacity is reduced by the factor. Beta LJ equals 1.075 minus 0.005 into LG by D. Provision for long grip joint. When grip length LG, total thickness of connecting plate, exceeds 5 times the diameter of the bolt, the shear capacity is reduced by the factor. Beta LG equals 8 times D by 3 times D plus LG. Consideration of packing plates. The packing plates are provided when the thickness of connecting plates in a butt joint differs. When the thickness of packing plate exceeds 6 millimeters, the shear stress is reduced by factor beta pk equals 1 minus 0.0125 tpk, where tpk is plate thickness in mm. Partial safety factors in steel. As per IS 800 Table 5, partial safety factors for materials are as follows. A. Resistance by ultimate stress, gamma ML equals 1.25. B. Resistance by yielding, gamma MO equals 1.1. C. Resistance by buckling, gamma MO equals 1.1. D. Resistance of connection for all type of bolts, gamma MB equals 1.25. Welds. Gamma M weld equals to 1.25 shop fabrications equals 1.5 field fabrication. Q1. The value of bulk modulus of steel is option A 100 GPa, option B 160 GPa, option C 200 GPa, option D 250 GPa. The right answer is option B. From IS 800, E equals 2 into 10 power 5 Newton per square mm. Poisson's ratio is 0.3. Substituting in relation, E equals 3K into 1 minus 2 mu. We get K equals 166.66 GPa. So, option B is correct. Question 2. The number of partial safety factors used in steel design is option A 4, option B 3, option C 5, option D 6. The right answer is option A 4. Question 3. If the connecting plates in a butt joint have thickness of 16 millimeters and 8 millimeters, the shear stress reduces by a factor 0.7, 0.8, 0.9, 0.85. The thickness of packing plate is 16 to 8 equals 8 millimeters. So beta pk equals 1 minus 0.0125 tpk equals 1 minus 0.0125 into 8 is equal to 0.9. Question 4. The number of shear planes in a lap joint consisting of 5 plates is 2, 3, 4, 5. The number of shear planes in a lap joint equals number of connecting plates minus 1. Hence right answer is option C4. Q5. If the bolt diameter is 20 millimeters, the maximum number of bolts that can be provided in a row of 140 millimeters width flat is 2, 3, 4, 5. Given D equals 20 millimeters, so minimum pitch equals 2.5 D equals 2.5 times 20 is equal to 50 millimeters. Minimum E equals 1.5 D, not D naught equals 22 mm equals 1.5 times 22 is equal to 33 millimeters. This is the figure when 2 bolts are provided. And this is the figure when 3 bolts are provided. When 3 bolts are provided, the minimum pitch and edge distances exceed the total width of the plate. Hence, only 2 bolts can be provided. Thank you, and subscribe to my channel for more such videos.